Hello everyone, welcome back to my channel. If this is the first time that you are seeing my videos, usually I talk about architecture in computer science, but I like to introduce other subjects like system thinking, decision-making frameworks and things like that, because all of them belong to this area of architecture. For you to be an architect or even a developer or software engineering, you need to, of course, technical skills, but you also need to take decisions. And if there is a way or frameworks that we can use to take those decisions, great. And that's why I'm introducing today these decision-making frameworks, and in this case, first principles. First principles, it's a very popular decision-making framework. It's high popularized, I hope I'm saying it right, by Elon Musk. At least it talks about it, where you take a decision based on facts and not by history or any kind of other bias that you have in your mind. For instance, you have to develop a project in computer science and people always think, okay, you should go microservices because it's the current trend. And this is not the right approach. When you use a decision framework like this one on first principles, we will see that we should take a different approach, and then we will decide if microservices or other architecture style is a good decision. This framework can be applied to any subject, not only computer science, and I mean any subject, and I'll provide you two examples that where you can apply this, one for a personal life and the other for computer science, so you can use it the way you want, of course. So let's start with our decision framework. So what is first principles thinking? First principles thinking is a problem-solving approach where you break down a problem into its most fundamental truths, not parts. It's not like you have a problem and you say, okay, I have this architecture, I'll split in these components and these services, and I take decision. No, we are at a meta level here, and we're saying, I have to take a decision, what is true about this decision, meaning I want to do something, what is true, what are my requirements, what money do I have, what technologies, for instance, can I do we use, for instance, in our company, what we expect in the future by the resource that we have, what are the real objectives, what are the real requirements, what are the real constraints, and then we take these truths, the things that are facts that we have available, and we take a decision. We don't try to, let's say, fit our requirements and constraints and things like that in something that we already have in our mind. It's the other way around. We have truths, facts, things that we know about our company, requirements, customers, and then we take a decision from there. Sometimes it's difficult, it seems easy, but it's not, because when we start to have a lot of experience, we think that we already know what will be the solution for a specific problem just by, let's say, after 5 minutes or 10 minutes in a meeting. But sometimes we are using the wrong way, and at the long term there will be issues because of that decision. So it forces you to pause, question everything, and rebuild your solution from the ground up based on core facts, not inherent habits. And for me, this sentence says everything that you should know about this first principles thinking. So let's see some details. Let's say we have a software architecture use case, meaning that every time we have to take decisions about the software architecture, usually it's as much about mindset as it is about technology. So too often teams default to trends, like I said before. Usually think of something like, okay, the trend is microservices, maybe it's good, it's new, it's good. I remember a TV show that was called How I Met Your Mother, and there was a guy there that always said that everything is new is better. But sometimes that's not correct, but it's just a fun fact. So too often teams default to trends, frameworks, or familiar patterns without deeply questioning if they are truly right for the problem at hand. So question your habits, question your trends, question your knowledge before taking a decision. And if you are an architect, there is always this question about why, or even if you are a software engineering, you always say, why am I taking this decision? What is the trade-off? What am I losing? What am I gaining with this? And try to be as agnostic and, let's say, critical thinking, or as they usually say, be intellectual honest. That's one of the things that applies for this decision framework if they are truly right for the problem at hand. Meaning, I will repeat, too often teams default to trends, frameworks, or familiar patterns without deeply question if they truly right for the problem at hand. This is really important. That's where first principles thinking becomes a game changer. Let's see how. Why software architects fall into analogy thinking. In tech, we are under pressure. That's one of the things, and sometimes you take decisions because, okay, this is for yesterday. It's a common expression. So fast deadlines, high complexity, shiny new tools. It's tempting to say everyone's moving to microservice or Kubernetes is the standard now, so we should use it. Maybe it's not the best solution for our company, for our startup, for our projects. Maybe we don't have money or even resource in the future to manage microservice or Kubernetes. Maybe a simple Docker, maybe a Monolith application is enough and more maintainable, and again enough for the objective of the application. But what is that? But if that's not the right fit for your problem, that's exactly when first principles thinks earns its place at the table. So a real example, should you use microservices? Okay, imagine you're leading the architecture of a new system and someone says, let's use microservice, it scales better and it's more modern. That's the common saying when we are discussing architectures nowadays. So that's reasoning by analogy, meaning that, okay, if everyone thinks it's okay, we should use it, at least we should give it a try. It's based on what worked for other companies, but most important, not necessarily what fits your case. And when you start to think this way, you start to become more senior, more architect if you are trying to achieve that position, or maybe you already are and you understand what I'm saying. Let's apply first principles thinking on this architectural decision. So first, define the core problem. So we're building a new digital platform, an internal application to manage human resource and payroll for 2,000 employees. And when we look into this, we start to think about, okay, payments and things about human resource. Let's see what can we break down on this application. So what do we know to be objectively true about this of a human resource? Let's say the system will be used internally, so not externally. That's one. It's a true fact, something that we previously said in when we start this video, this presentation. So this is the facts that are true about our project. So load will be predictable and relatively low because it's just 2,000 employees as we have here, employees. Okay, so we know that it's predictable and relatively low, meaning that it's in our control. Everything is in our control. We know when we hire new people, so we know what is the growth of of the traffic for our application. So the team has limited DevOps experience. Imagine that we are a startup or something and we don't have too much experience in DevOps, or we just have one or two persons. Maybe it's an external person or a part-time person if this company is small. If the company is big, maybe we have two or two persons. Maybe our company, it's not even IT, and we are outsourcing these kind of things. These are all of them true facts about the requirements. Development time is tight, so we don't have too much time. Features are tightly coupled, meaning that everything that we'll be developing, it's related with each human resource. There is no completely model that it's completely decoupled in terms of business logic. So HR and payroll data are interdependent. So we pay because we have human resource. They are really coupled, this kind of two things. At the first sight, we can think about a system and microservice architectures that say, okay, you have a model for human resource, another one for payrolls, and others that we'll see in a moment. But at the end of the day, the business logic, it's really interdependent. So should we really put some microservice on it? So there is no business requirement for independently deployable models yet. There is no reason to create separate models to be used by other entities. All of the models that you can think about this solution are related. So maybe it's something that we should think about, some evidence that maybe microservice is not the best approach. So again, this is just a diagram. So we identify the problem, fundamental true, and about some of the fundamental truths, we deduce another fundamental true, and then we take a final decision. And we are reaching that, so we are now on our third step, rebuild from the ground up. So from these truths, what should you prioritize? Simplicity of deployment and debugging. That's because our team is not experienced in DevOps. Everything is internal. Maybe you are not even an IT company. So simplicity of deployment and debugging. We want it should be simple because maybe we want to add new features. It's an internal application. We want to deploy fast. We don't want to sync with other models, with other teams, or and if the models are connecting using HTTP in a microservice architecture or even sourcing or things like that, it will be a complicated task just to deploy sometimes just small changes in our application. So strong data consistency between models. There is a high coupling between the models in our application because it's about human resource and it's internal, it's for our company. We are not working with outside entities, so there is no reason to create loosely coupled models. Fast delivery of features. We are always trying to create new features, and we want to be we want them to be deployed quite fast. So simplicity of deployment and debugging, fast delivery of features, and low operational overhead. We don't have people. Since it's an internal application, so there is no revenue around this application, meaning that every time someone spends time, let's say, in this application, well, just losing money. We will not receive money from this application, okay? So what does that suggest? Okay, so let's see a comparison of a possible architecture design. So in the monolith architecture, means that we have a big application. Maybe internal, we have some models. Maybe they are packaged jars if it's in Java, or maybe they are Python files or Go or any other application. But at the end of the day, we can split these in models, but they are just direct calls in the code. We can enrich this one, and every time we change something on the leave management model, we know it's quite easy to change the employee management, and then we deploy the whole application. If you go to a microservice architecture, so we have a service here that connects HTTP to this one, to this one, to this one. Every time we have to change something, maybe we have to change the API, maybe you can version the API, but then again we have to probably change something here to call a different thing here, and you have to deploy this one. They both have their own database, which is a common practice in microservice architecture. So again, issues around this deployment. So you need more expertise here in DevOps, and if you record, the team has limited DevOps experience, and it was objectively true. So we don't want too much work on the DevOps deployment and operations on this application. So this one probably should be the one that we should target, considering all of the items that we think are objectively true. Okay. Maybe this can change in the future, and we change to a microservice architecture. Imagine to create a big application, we merge with another company, and then now we have to extend our application or integrate it, then that will be the case. But then again, the facts that are objectively true, they will change. So we refine and reconsider, and maybe we should refactor our application. But at this time, taking into consideration all the facts that were presented, we think that monolith architect, it's the best one. So a modular monolith or a well-layered application might be the better choice. It allows clean separation of concerns in the code and making the deployment quite easy onboarding for devs and familiar distributed systems, meaning that any developer can change this application because it's in the code. If something goes wrong and you have a good test coverage, it will be easier to find the bug. In this one, it can be really complicated. Where is the issue? Or imagine if you need some transaction mechanism here, you have to consider patterns like the sagas and things like that. It's not the best approach for internal application, where in the company there are limited knowledge about distributed applications. We have a limited operations team and the DevOps team. So Monolith, it's for sure the best approach. So much faster development and release cycles. By using first principle thinking, you've gone from we need microservices because everyone else uses them to we need a clean, maintainable, and fast to deploy system based on our current reality. And that's where this first principle thinking, this framework shines. So the payoff, a year later, the system is live, maintainable, and evolving well. You've saved hundreds of engineering hours that will be spent maintaining networked services service discovery, distributed tracing, and more, because there are a lot of things that are not business related in a microservice architecture. So all of which weren't needed in your actual use case. You will also avoid the cool tech trap and made a solid architectural decision grounded in reality. And I will repeat this, and made a solid architectural decision grounded in reality, meaning the first principles thinking based on true facts about what we really want and have, and what can we do with the things that we have. Okay, I really like this decision framework. So first principles, meaning better architects. Here's the truth: the best architects are the ones who know the most tools. They are the ones who think clearly under uncertainty. And for that, you need a good decision frameworks. And that's one of the reasons I start to introduce the first principles. And I promise you that I will provide other ones that can help you in different, let's say, different type of decisions. Because the first principles is good when we start a few projects and you have to take a real decision about something. But now imagine that you have requirements and things like that. Maybe the first principles is not the best approach. Maybe you want to filter something and prioritize things. That will be different decisions frameworks that I will certainly address in future videos. So first, the principles thinkers helps you cut through the tech hype, which is a very common, and I talk about myself. I'm that guy also. So but currently I'm an architect, so I have to be more moderate in my decisions. Avoid cargo culting patterns that don't fit. Make architecture decisions that age well. This is quite important. So next time you're designing a system, don't start with patterns or frameworks. Start with the question, what is true about our problem and what do we actually need? And this is quite important because it demands that you talk with all the stakeholders, the product owner and everyone, so you can understand what is really true. And meaning, and don't be afraid to talk about what is the budget, what is the constraints that we have. There will be the need to hire new people, and maybe the strategy of the company. We don't want to hire anyone. We are on the limit of our budget. This is the actual facts, the truth ones that you should take into consideration to make a decision. Probably you don't like it. Maybe say, I prefer this architecture style, but due to the constraints that you have, the true facts, maybe you should choose a different architecture. Okay, that's what I want to present about this decision framework. I hope it's useful for you. I hope it's a new thing that I'm introducing and you really like it. So provide your comments, share with your friends, help me to make my channel grow. So I always have motivation to talk about all of these things that I usually do on my daily basis as an architect, and I really like to share all this knowledge. So thank you for watching.